my name's Melissa, and I'm a Blue Coat here at Science North. I'm here today because we got asked last week by Pure Country 91.7 if we could offer a theory about something that was trending online through Domino's channels. And Domino's Pizza said that if you want to microwave pizza, better the next day, you add a glass of water into the microwave with the pizza. Now that's kind of interesting, and before Science North offered up a theory, my question really is, does this actually work? So follow me, we're gonna see what we can figure out. So I often have friends and family that send me videos, they ask me, hey, how does this work? And a lot of times, the unfortunate thing is that sometimes it just doesn't work. If you see something online that might be sort of unbelievable, you shouldn't believe it. So for me, if you've ever heard of Edward de Bono's 6 thinking hats, we assign a different color hat to how different people think. Now for me, I think a lot with the black hat. The black hat is the hat of caution and critical thinking. Now that serves me well as a scientist. What the black hat kind of does for me is it won't let me offer a theory about how the pizza hack works unless I can prove that the pizza hack really works. So here I am with the black hat, and I said that I question a lot of things, and it might be kind of annoying to my family and friends, like I mentioned before. Whenever they tell me something, they try to be like, oh, this is so cool, and I'm like, nah, I don't believe you. And then I have to go see if I can look it up myself. So here I am at the internet trying to figure out who made this claim and why. Before I order the pizza to try it out, I want to dig a little deeper into the trend and see what I can find. So I did a couple different Google searches. I found several recent articles within the past couple weeks talking about the new pizza hack from Domino's, and this represents the trend that we're told about. So I did a little more digging, and I found the original blog post, and it was posted by Domino's Australia. So that was kind of interesting. The fact that the hack comes from an official Domino's channel lends it a little bit more credibility. They don't want to represent things in a way that makes them look bad. But what was really lacking for me from this original source was there was no science, there was no data, there was no reference to researchers. So although there were lots of different links in the Google search, they all started from that one claim, the Domino's claim, that really didn't look like it was verified. Domino's even said in that original post that it was not necessarily reliable and not guaranteed. So we'll take that for what it's worth. And what if I wanted to verify this myself with some science? Well, then I would need to design a science experiment. Maybe now's the time to order some pizza. So in order to have a good experiment, we have to answer a very specific question. So I could ask maybe, what's the best way to reheat pizza in the microwave? Well, that's really broad. I would have to design a series of experiments in order to do that. And I really want to try to stay true to that Domino's blog. So I think the question that we're going to try to answer, we want to control for a certain amount of things. So we're going to use 1 slice of pizza with water for 30 seconds, and 1 slice of pizza without water for 30 seconds. So that's going to be our comparison. Now, another thing that we want to do when we're thinking about the scientific method, we want to do a bit of research. So I've done a little bit of that. What do I know about microwaves? Well, from being a human that lives on planet Earth who's used the microwave before, I know a few things. I know that if you put bread in the microwave for too long, it gets like hard, so kind of like the crust. I know if you put cheese in and it gets too hot, it gets like bubbly and rubbery. Certain things, if you put more stuff in the microwave, you need more time to warm it up. Some things don't warm up very evenly in the microwave, like you got a hot spot and a cold spot, like lasagna. I'm looking at you. So I know those things. Now, what about how a microwave actually works? So, maybe I best get a whiteboard. A microwave works by transforming electricity. So it takes electricity out of the wall, it's got to be plugged in, and it transforms the energy into electromagnetic radiation. So microwaves. So I'm gonna draw some waves here. There's like my artistic depiction of electromagnetic waves inside the microwave. So when we turn on the microwave at a certain power, it's gonna have a certain amount of waves that go through it. And that energy gets transformed to heat inside our food. Now, different molecules in food are going to behave differently in the electromagnetic field. So those tiny particles all have different properties and they behave differently. So water is going to be affected by the waves differently than, say, fat or protein. Those are other things that are in food a lot. So what else do I know about microwaves? I know that I didn't know this before, but I found out now that there are some applications where scientists will use a glass of water and they call it a dummy load. And they put it into the microwave with something that they're warming up. And the water can absorb some of those microwaves. There's always the same amount of microwaves that are in there, right? So if there's extra load, then some of that energy gets absorbed. So that's a little bit of a precedent for what we're saying about the pizza here. So now that I've done sort of all the research, the next part of the scientific method is making a hypothesis. So that's sort of like my educated guess. What do I think's gonna happen? I'm gonna grab a pizza. I'm going to hypothesize that adding a glass of water is going to improve the crust. It should make it heat up a little bit more evenly than without, but you really have to test it out. All right, so I've got some sweet leftover cold pizza. Now I was going to choose a cheese pizza because it would have the toppings sort of spread most evenly. We want to try to keep our conditions similar, right? We want to control for variables. I decided to go with pep and cheese though because it is classic. Now there is a tiny little bit of difference. I tried to pick the pieces of pizza that were the most similar in size, but you can see with like the toppings there are a little bit different from one pizza to the next. So that's one limitation to this experiment. So let's maybe just do the honors. I'm gonna pop this guy in there. Okay, 30 seconds. Let's see. So while that's going, how am I going to measure this? Crispiness isn't really something that you have a tool to measure, like a ruler, ruler gives centimeters. What is crispiness? So I'll be touching it, do a little bit of an analysis, and I said it might warm up more evenly. So I'm going to test it out with this thermometer at different spots to see if it's uniform throughout. So we can hear it crackling already. Let's see. Okay, it's bubbling. Sizzling. The cheese kind of separated. It did that thing that I kind of mentioned. So let's see. It's like 86 degrees on the top. Oh, it's like 93, 96 over here. Let's do that bubbly spot. 94. So there are some spots that are still cold, some spots that are still hot. What about the crispy? It says that it's supposed to not be soggy. Well, this is it's hot. This is a soggy pizza. This is without the glass of water, right? So this is our sort of our control. And you can see it's very soggy. It still kind of looks delicious, not gonna lie. But let's try out the other piece with the water. So let's compare to the next slice of pizza with the glass of water. So here's the hack. Let's see if it sort of improves. So my hypothesis here is that the water is going to be absorbing some of those microwaves. So not all the energy is going to go into that piece of pizza. Now, one thing we kind of already know, microwaving is probably the quickest way to heat up a pizza, but it's not really the best if what you're going for is crispy. We kind of know that if you want to be patient and do it in the oven, you probably get a bit better results. But you might be really hangry. And filling up a little glass of water halfway and adding it. Now, something interesting to note, the water isn't hot enough that it boiled. If it were to have boiled, then we would have been adding a lot more moisture into the microwave, which kind of goes against what we want is a not soggy pizza. So let's pull this out and compare. I can already tell right away it's not as hot as the last piece. Let's try that out with the temperature gun. So this piece is colder overall than the last piece. So some of that energy from the microwave went into the glass of water. So I would say it's not any more crispy. I would say it's less soggy, but it is less hot. So really it kind of depends on your preference here. So have I kind of proved one way or the other whether it works? Well, I wouldn't use the descriptor of crispy. I would say less soggy, maybe. So I've got soggy pizza and I've got a little bit less soggy pizza. Now I think that's because I added the water in with this slice and the water absorbed a few of those microwaves. Now, what I really want you to think about today is question everything. Right? We don't want to believe everything that we want to see or that we see on the internet. We always want to wear the hat of caution and critical thinking. So which one do you prefer? Soggy or less soggy?
Less soggy.
Less soggy? You know what I prefer? I prefer cold pizza.